Hello, everyone, and welcome to Generative Geek. Today's episode is going to feature a nice part of the project that we are building. We'll take a YouTube video, we'll strip the MP3 out of the video, then we'll push the MP3 to Whisper, which is an OpenAI's open source model. The model is also available as an API. I'm going to use the self hosted model so that it's free for us. And then we are going to generate transcripts out of the using the model. Those transcripts obviously are going to be large and cannot be passed as a single prompt. So we're going to split them out into various chunks, convert them into embeddings, and store them in Chroma. Right. So this is my larger goal for today. But what I'll also do is once I have things in Chroma, I will try to see if I can help you with a quick introduction on retrieval as well. Like, we'll present a user query, we'll send that query to Chroma, we'll get something back, then we'll add that to the prompt, push it to the LLM, and see what answers are coming back. I hope you will like this video and you will learn something new and interesting out of it. We'll be using Google Colab for this video, and the description of the Colab notebook. Link for the Colab notebook is part of the description for the video. Let's get started. Okay, guys, so I am on Colab. Once you are on Colab, what you need to do is change your runtime, right? So change runtime type, ensure you are on a T4 GPU. If you are on a paid version, you can select even more powerful GPUs like 800 or V100. But if you are, let's say, on a free version of Colab, select the T4 GPU, right? So once this is done, we'll get started with installing some libraries. We'll first install Pytube. Pytube will help us get the necessary YouTube video downloaded, and we can take the audio itself out from the video, right, using Pytube. Next, what we need is Whisper. So if you go to github.com/openai/whisper, you can see that one easy way of installing Whisper is that if we use, let's say, this command, right? So I'm just going to copy this command, run it here, right? So yeah, now if I run these two commands, what is going to happen is Pytube is going to get downloaded, and I'll have Whisper also, the necessary libraries installed. Once these two things are done, we'll be in a state where we can then go out and install, download the relevant video that we want. For the purposes of this demonstration, I'm going to work with this video. I don't know if you guys have already seen this video. If you have not and you are very interested in generative AI, I strongly recommend that you watch this video by R.A.G. Karpathy. It's called Let's Build GPT. It was released around a year ago. It's a wonderful video that helps you get the sense of how these transformer models actually work, right? So we'll take this URL. I'll come back while this installation is still going on. I'll say YT underscore videos, and we can create a list here which will then say that, hey, these are the videos that we are interested in, right? So once we have these videos, the list of these videos ready, we can then go out, use Pytube to pull these videos out, right? So I can say from for video in YT underscore videos. While the previous cell is still going on, I can still go out, assume that Pytube is installed. I can still go out, write some code, right? And Colab is already giving me some interesting auto completions, right? So I will call Pytube YouTube. I think I forgot to import from Pytube. Okay, it's giving me from Pytube, import YouTube for video. In this, we'll just say YT is equal to YouTube video. Next, what we'll do is we'll say audio is equal to YouTube, sorry, yt.streams.filter only underscore audio. This will only give us the audio, dot first, right? And if we say audio dot download, you will see that if you go to the folders here, you will see that video appear here, right? So you can see here that video, Let's Build GPT, and you can also see that the default name is same as the name of the YouTube video, right? We can change that. We can pass in a new name here. Whatever you pass in here will become the name. I'm not doing that right now, but that's my intent, right? I'm going to do that in a while. uh, I just wanted to show you that how this thing works. Now what I want is then I don't want my things to be ephemeral, in the sense we are connected to this T4 instance, but the moment we disconnect, all of this is going to go away. So I want to save some of these audios, some of these audio transcripts that we are going to build in a more permanent storage like a Google Drive, right? So I want to now work with Google Drive. So we'll say from Google.Colab import drive. And the way you basically go out and import Google Drive or mount Google Drive is, you say, then once your import is done, drive.mount slash content slash drive, right? And if I now run this, and let me just move these things in a different cell, um, is, if you run this cell now, you will see a permission or an authorization popping up, right? So let's just run this cell. It will say, hey, permit this notebook to access your Google Drive. Okay, let's do that. Just select the relevant account. Continue. Once this is done, your Google Drive is going to get mounted. And what we'll do is, instead of just saying audio to download, I'll now present a folder here, so that I'm not just saving the file locally in some ephemeral storage. I'm actually saving it in my Google Drive, right? So you say output underscore path is equal to slash content, and this is how you basically use Google Drive, right? So my drive slash let's just name it something, R.A.G underscore tutorial underscore samples, right? So that's the folder name I'm giving. And we'll basically just save our audio here, right? So now if I run this, now let's just run this and go to my Google Drive. I can just say home, folders. I still don't see the folder that I gave. Okay, now I see RAG tutorial samples. Let's see if the relevant file is there. Yeah. So you see the default name of this MP4 that is getting downloaded is same as the video name, right? So, but you can obviously change it, but this is the default name. Now we have the file available in a more permanent storage. What we now need is that we need to now invoke Whisper. So the way here to invoke Whisper is that, let's just time this for now. We'll time this entire cell. I'll import pathlib, then I'll import Whisper. Next, what we'll do is we'll have to download the model. So while the library is there, we still need to download the model. And if you go to the Whisper GitHub page, you can see that there are lots of various sizes in which these models come. I'm going to download the medium one. As you grow up in size, your accuracy tends to get better. Medium is perfectly decent for our kind of requirement. So we'll say model path is pathlib.path, and we have to specify where should we actually go out and save this model, right? So I'm going to save it in slash content slash models, and we'll then say if model path exists, then print that model exists, right? So else, okay, is something wrong? I was expecting Colab to do the indentation. Starting download of Whisper model. Yeah. So, and then you say whisper dot underscore download. You give it whisper dot models dot underscore models medium, right? So next you specify where should this go, and this has to be a list. So it's a dictionary basically. So slash content slash models false. Yeah. Let's run this. Once we do this, we'll have to load the model. I'm going to load the model in the same command. Earlier, I was thinking of loading it in a different cell, but I think it makes sense. And we have access to a GPU, so device is CP, not a CPU, but CUDA. If you are on CPU, you should say CPU. Download underscore root is slash content slash models, right? So let's just run this. This will now go out and download the model, right? So if you look here, it says that this is 769 million parameters on which this model is trained, right? Now come back. POSIX path has no attribute exist. Should be exist. So these kind of things happen when you are typing on the go. You should be quick to, if let's just say if it was some other error. Generally, my go-to model these days is to just ask Colab AI. But let's say if Colab AI is not the right tool for you, just do a Stack Overflow or a Google search and you will get the answer, right? So I think the download is done. Download complete. Why is it re-downloading? Okay, maybe it's loading, but I can see it's downloading. So something is wrong. Generally, I don't run this in the same cell. And maybe what I did was there was a model path, and I don't know, something went wrong. I don't know why it had to re-download. It should not have done the re-downloading. Now, okay, never mind. Now that the model is available, we now will go out and so if you see here, you see models, you can see medium.pt. Okay, I think there was a problem. We put by mistake a dot here. That's why it had to re-download. Let me just show you this thing again. Let me delete these folders. Yeah, let me delete these folders, not this folder. Maybe I'll just see, I'll take this out of this thing and now rerun it and see if it loads quickly or does it go out and download again. I don't see it printing anything, so that means it's not downloading anything again. Or no, is it? Because I still see a models dot something. Okay, maybe what has happened is we had to rerun the above cell. uh, okay, this was not down deleted. Let me just delete it again. um, and now delete the folder. Same with this. What I want to show you is that we don't need to re-download the folder, right? So sorry, re-download the model. Once the model is downloaded, even in an ephemeral storage, till you are connected with the runtime, you don't need, right? Slash content slash models. Okay, this seems okay. Now let's just see. It's again downloading the Whisper model, and here this time around it should not, right? So if we just go here, we see a models folder coming up. Earlier there was by mistake an extra dot, and it treated that as a new folder, where it thought it has to keep the files, right? So keep the model. This time I don't see it doing this thing again. The model is loading, but I don't think it's downloading anything, which is good. It takes a little while to load because it has to take the model, put it into the RAM. So the model is now loaded. Next is where we have to make use of the model and transcribe our results, right? So I'm going to time this, and we're going to say result is equal to model dot transcribe, and here you have to give the entire path, right, of the file. This thing is Colab AI is doing a wonderful work for me, except for the last part. The file name is not right. I'll come here, say rename, grab the entire file name, go back, press this. So this is where now once I start running this cell, it will take a little while, guys. Be patient with it. on a T4 GPU, on a free account, it should take anywhere between 13 to 18 minutes for this video, 20 minutes maybe max, right? So let it run. Go grab yourself some water, tea, coffee. I'll do that myself, and we'll come back once this thing is done, right? Okay, so now the results are in. It took around 19 minutes and 40 seconds for the entire transcription to happen. What I've done is I've taken the transcription in a variable called result, and now we have another variable called transcript, which is nothing but result. Within result there is a text. I've just taken the text from the result, and we have printed the first 200 words out of it. So if you see, it just says hi everyone. So by now you've probably heard of ChatGPT. It has taken the world and the AI community. So the first 200 words are out. What we'll now do is, I just wanted to show you that this our transcription is ready. We'll now go out and install some Langchain libraries. So pip install Langchain, pip install Langchain underscore community, pip install Langchain underscore OpenAI. Some of these libraries that we are now installing will be used when we now invoke Langchain for our for various jobs related to storing the embeddings and also querying the embeddings, right? If you remember, when we go back, right, the way it works is, we now have the YouTube video. We took the mp3 out. We are now at this stage where the transcripts are available with us. We now need to take these transcripts, load them as documents, and then split and chunk them, and then convert them into vector embeddings for storage into Chroma, right? So we have come up to the point where our transcripts are now available with us. Go back here. The loading is still happening. Once this is done, what we'll do is, I'll quickly go out and create some code which will help me now. R.A.G underscore tutorial underscore samples. Just to save some time, I generally have some snippets of code ready. So I have now, and we'll just import OS. So I have in my this RAG tutorial sample, I'm going to save the entire transcript, right? I'll write this transcript because it takes like 19 minutes. If you lose this transcript, it'll take you 19 minutes to again generate the transcript. So it's better you write the transcript in some sort of a permanent storage, and I'm doing that with Google Drive. So if we come to Google Drive now, you can see that the transcript.txt is now available here. I can quickly do a double click on it. And hi everyone. So by now you've probably heard of ChatGPT. We see the same thing here as a TXT file now, right? So with this, our transcript is now stored. All our libraries are installed. Langchain libraries are installed. Now let's go out and load this using a document loader. So we'll use from Langchain underscore community dot document underscore loaders import text loader, right? If you remember in the previous video, when we were doing the PDF part, right, when we were doing this part of it, we used the PyPDF loader. This time we are using the text loader from the document loaders, and I can just go here and show you how, what I mean. You go to Langchain, and this is the loader I'm talking about, right? So the method is very simple. If you remember from the previous video, you just take the document, that the text document that you want to load, and you do a loader.load. That will give you a list of documents, right? So let's just see here. So from Langchain underscore community, we'll just say doc loader is equal to text loader, and I'll give it the file underscore path. This At this point, we'll basically pass our entire Google Drive path again. content slash drive slash my drive slash RAG underscore tutorial underscore samples slash transcript dot txt. Yeah, so this is the file which I want to load, and once this is available, I'll say loader is equal to loader dot load. I'll say these are docs, so docs is equal to loader dot load. And let's run this. If it runs fine, we'll just go out, print the first 5 documents, and most probably what will happen is this is just one document, I think. So let's just see len of docs. It's just one document because this entire thing was in one file and just took it and loaded one file, right? So we have now len of docs is one. What we'll now do is we'll go out and use this document that we have to create a split, right? We'll just go out. We are at a point where the documents exist. We now need the chunks. So so we'll say chunks. Before we go to chunks, we'll just start importing from Langchain underscore text underscore splitters, import recursive character text splitter. This is the splitter we are going to use. And let's just say I'll accept most of it, except that chunk size should be 2000 for me. Text splitter is recursive character text splitter. Chunk size 2000, chunk overlap 100. Text is equal to text splitter dot split documents. This is a document. So, and then you say docs. Yeah, so this looks good. I'll also just say print f split len of docs, len of docs, sorry, len of docs into len of, let's just call it chunks. I prefer to call them chunks. Len of chunks into these many chunks. Yeah, let's run this. This will tell us that there was one split, one doc. There was one document and it has split it into 58 chunks. That's what we got back. Now what we'll do is, if you just want to have a look, we can now say just print the first 2 chunks for me. um, and you can see that this is the first chunk where it says document page content, and this is the second one, right? So this is how it goes. It is also giving you some metadata on what the source is. Now what we'll do is we'll go out and get started with. So we are now here, right? So we have our chunks ready. We now need to store them in Chroma, right? So we, in order to store them into Chroma, we'll first do a pip install Chroma db. You need this because for all the Langchain libraries to work, necessary libraries to work, Chroma is required. So I think it's going out and installing things. Requirement already satisfied. Okay, I think I already have Chroma. Maybe this instance already has Chroma, so which is a good thing. Now what we'll do is I'll use get pass. So from get pass, import get pass. Get pass is for putting in your keys secretly, though Colab offers a secret manager. I'm not using it as part of this video. Maybe in a future video I will get into it. um, from Langchain underscore OpenAI, import OpenAI embeddings. Yeah, and we'll just say OpenAI underscore API underscore key is equal to get pass, enter the OpenAI API key. Yeah. So this is basically the key. That this is the part where you will, when you run this, you will get prompted for a key. We'll next load Chroma. So we'll say from Langchain underscore community dot vector stores import chroma. Yeah. So if you want to see this, again, just do a Google search, and you will see that there's a lot of documentation on how you do various things. How do you do a similarity search? How do you update a document? Langchain community document is available. And Langchain has like a really nice documentation, so you can have a look at it. It has various things on, how vector stores are working, how things work. I really think you should have a look at it, right? So from Langchain underscore community dot vector stores import chroma. Next, what we do is, for like we discussed during our chroma DB videos, that you need two things. You need an embedding function, and you need a name of the collection, right? So OpenAI embeddings, and you say OpenAI API key is OpenAI API key. Next, we'll say storage directory. We'll just pass a storage directory because we want this to persist. So we'll say embeddings slash chroma. Next, we'll say vector db is equal to chroma. You pass persist underscore directory is equal to storage underscore directory. Embedding underscore function is equal to embedding underscore function. Yeah. So we are providing an embedding function. I don't need, let it auto figure out. Once this is done, we'll say vector db dot persist. Next, yeah, we'll just say db is equal to, yeah. So let's just uh, do till here. Generally I don't have these things in the same cell, so let's just move to the next cell, because in this cell we are asking for a user input. So let's just run this cell. Once you do this, you will get enter the OpenAI API key. This is the point where you need to go out, grab your OpenAI API key, come back, right? So I have entered my OpenAI API key, and now just plus enter. With this, my OpenAI API key is done. Now let's see what happens here. Do we get some error, or okay? It says that something is deprecated, which is okay. Docs are automatically persisted, so we probably don't need to do a persistence, and it's okay. In future when we get an error, we'll figure that out, right? So that's not a problem right now. Now what we'll do is we'll just say that, hey, we have a vector db. I'm just going to say db is equal to, what we are doing here is we are passing the chunks, and we are passing the embedding function, and we're saying this becomes my storage, right? So let's just do it. Once we do that, uh, it should, okay, now it has persisted. At this point we have basically achieved this thing, right? Our all our document chunks are now in chroma. Embedding function that we used was OpenAI embedding. It would have called the necessary library, and if your key was wrong, this would have failed. But because our key was right, this went. Now let me just quickly show you a retrieval QA chain. If you go here and say retrieval QA chain Langchain, um, and you come here, okay, this is not Python. Surprisingly, I'm not getting, okay, but never mind. We have the API reference document. So here you can see that, there is a chain called retrieval QA. It's a retrieval question answer chain. All I want to do is right now just show you how to build a retrieval QA chain, right? So what we'll do is we'll we'll say from Langchain dot chains import retrieval QA, right? And from Langchain underscore OpenAI import chat OpenAI, right? Next, we'll say LLM is chat OpenAI. Temperature is equal to 0. And OpenAI API key is OpenAI API key. We'll next set up QA, which is the query agent or the question answer chain. We'll just say retrieval QA dot from underscore chain underscore type. We'll pass it an LLM and we'll say chain type is stuff. The reason I'm using stuff here, like we discussed when we were talking about large PDF summarizations, here I can use stuff because now I'm retrieving the query using you from some sort of a retriever, right? So you will see what I mean. I'm not passing the entire document here. So you will say retriever is the same thing that we used for persisting our documents. Like the variable was called db. db is equal to chroma.from documents. We are now using it as a retriever, right? So you do that and then we'll run some query, right? So let's say we say query is equal to what is the primary goal of the, or what is the discussion of this video about, right? So let's just see what comes back, right? And I'll say query qa.run and we'll pass it the query. Now what is happening is it will get something from the retriever out. It will say, hey, you know what, the chain is tough and I have to use this LLM. So the retrieval part that we discussed here, right? I'm sending some query. It is the query is going to go into Chroma. Chroma is going to send some reply back. We'll add it to the prompt and we'll send that to the LLM, right? Our prompt is basically the same question that I am asking, and with that, there is some extra context that is getting set, right? So qa.run query, let's just run this and see what comes back, right? It says the discussion in the video is about implementing a transformer neural network, specifically focusing on self attention and multi headed self attention. The speaker goes through the process of building a transformer model from scratch, training it on a small data set, and generating text output. They also touch on regularization techniques, hyperparameters, and optimization strategies to improve the performance of deep neural networks like transformers. So you see how it took a simple query that I asked, picked something that was ingested in the database, sent it to the LLM, and we got a very nice answer back, right? If we had not done that, our answer would have been very, very different, right? So let's just say if I had done only a pickup of the similar embeddings from Chroma, I might not have got such a beautiful answer. There is another chain I want to talk about, which kind of helps you see that the model is not hallucinating, is called the retrieval QA with sources chain, right? So the way you do that is from langchain.chains, import retrieval QA with sources chain, right? So this is another chain and you will see the output is largely very similar. We'll use everything same, but we'll say QA with sources is retrieval QA with sources from chain type retrieval. Everything remains the same, nothing changes. It's just that maybe what we'll do is LLM, anyways we have set temperature as 0, and we'll say QA with sources. So we'll say results is equal to QA with sources and we'll pass the question. Here you pass a question. What is the discussion of this video about? And we'll just say return only outputs, and that's true. And we'll then print the results. Yeah. Now, if you look at this response that comes back, you will see that the answer is the discussion in the video is about training transformers and any given text using Nano GPT, a simple implementation with 2 files of 300 lines of code, and all of that. And it also gives you source, right? That hey, I'm referring to this. So you see how the answer is so very different when you are using a retrieval QA with sources chain um, and these two are very different answers. But the key point here is not that. The key point here is that you are also seeing that what is the source it is referring to, and the source it is referring to is this transcript.txt file. So this was it, guys. What we have done in this tutorial is we went through this entire loop where we took one YouTube video, we got the mp3 back, then we transcribed it using Whisper. We took the transcripts, converted them into a document and the document chunks, stored them in Chroma, and then using things from Chroma, we got the answer back. Whatever documents we got back, we then added them to the prompt as a stuff chain. And if in stuff, you basically just pass everything in the prompt, right? So you are not like, chunking any further. In the last video we have already discussed other methods like, map reduce, but this in this for this specific section we picked stuff. Now we send it to the LLM, we get the answers back. So this is it. I hope it makes sense to you, and if you liked it, do like, subscribe, comment. It really acts as a boost. In the next video, what we'll do is we'll basically start bringing everything together, where we have now individually done the PDF and the YouTube. Now we'll bring everything together and we'll add more YouTube videos and more PDFs, right? So we'll make a decent size repository, and then you build a Streamlit driven app which will allow us to do these queries, right? And we'll see what answers are coming back. It'll be a fun project. Thank you so much.